What are you looking for in your next automobile? Design, luxury, performance.
What about something with lower emissions that's better for the environment?
Faster, sleeker, and greener. Meet today's new breed of electric car.
Electric vehicles have been around for a long time, at least as long as cars with internal combustion engines. But one of the big problems early electric cars faced then is still with us today. How do you haul around enough stored energy to get where you need to go? Most cars carry potential energy in the form of fuel, but electric cars depend on the energy you can store in a battery. Think about a rechargeable battery. Usually when you get it, it's dead. All the ions and electrons inside are comfortable and exactly where they want to be. But then you change the situation. You charge it. Electricity makes the lithium ions move from one part of the battery to another by changing which material the lithium wants to hang out with. This is like if you push a boulder up a hill or pull back the arm of a mousetrap, except the electricity is doing the work for you. All these systems are now full of potential energy, just waiting to be released. The electrons have to move across the external circuit to get where they want to go, because only the lithium ions can move through the electrolyte. And when the electrons move, the lithium ions move too, back to where they started. We can use this back and forth, keep charging and discharging the battery for quite a while, but not forever. Researchers are working hard to develop batteries that have plenty of power, short charge time, long life, and improved safety.
My project focuses more on making safer batteries. Everybody knows that lithium-ion batteries are very powerful, and that's what makes them desirable for, cameras and cell phones. When you make a powerful battery that's big enough to power a car, it's dangerous, and the components inside have the potential to catch fire or explode even. Most lithium-ion batteries contain a great deal of cobalt, but this material contains no cobalt.
And
cobalt is toxic.
Heavy metal and very bad.
Yeah. It's toxic for the environment and dangerous for people.
So that's what you working on those different kinds of materials that go into the batteries?
Exactly.
Okay.
Exactly.
Over at MIT, a team of engineers has replaced the gasoline engine in this classic sports car with an electric motor. Who says science can't have style?
This is our Porsche 914 electric vehicle. It's run by pure battery electric power and you use an electric motor to drive. This car is better than gasoline cars because it runs off pure electricity with zero emissions, meaning it's a lot cleaner and a lot more environmentally friendly. So an electric car is very simple. It has a battery to power the motor and an electric motor to turn the wheels. Additionally, there's a charger to recharge the batteries. That's pretty much all there is to an electric car.
So instead of stopping at a gas station after you've been driving around all day, you come home and just plug in your car, like you do with your cell phone when it's running low. But the thing is, you're charging your car with electricity from our national power grid. And right now, that grid is fed by energy sources that aren't so clean. Even so, electric vehicles are still lower in emissions and more efficient energy users than combustion-powered cars.
We were able to get the equivalent of 164 miles per gallon. Well, for average driving between the city and the highway, you'd expect about 100 miles for one charge. Depending how you drive, you can get a lot more than that or a lot less. With the charger that's built in, it takes about 12 hours, so it would charge overnight.
Wait, I have to leave my car plugged in for 12 hours before it's fully charged? Isn't there a faster way?
We're currently exploring rapid recharge as an option as opposed to charging overnight. The idea being that you can charge your car overnight like any other electric car, but also charge it in 10 minutes if you need to go on a long distance trip. Go home after driving around 50 miles, charge the car the rest of the way, and drive the next day. But if you need to go on a long distance trip, say from New York to Boston, you can drive 200 miles, stop for 10 minutes and recharge and continue on your way.
Rapid recharge isn't the only option for speeding up the charge process. One company is going a different route entirely. building battery switching stations to get you back on the road in less time than it takes to fill up your gas tank. This all sounds good, but let's talk speed and performance. How do electric vehicles compare with other kinds of cars?
So this Porsche, unlike the original Porsche, has a little less horsepower, but it has a lot more torque. So it can go from 0 to 40 rather quickly, but from 0 to 60 it's a little slower. It still reaches a top speed of close to 100 miles an hour. There's no real limit to it. The electric Porsche would probably beat the regular Porsche off the line and the red light.
Huh, not bad. As concerns for the environment and rising prices of fossil fuels continue, we're going to see lots more electric cars hitting the road, in all kinds of models and sizes. Who knows? Thanks to improving technologies, someday all our cars might be sleek, shiny, and electric. And as we shift more and more to renewable energy sources, driving to the mall will get cleaner and greener. Because you shouldn't have to compromise your conscience for cool.